So we're looking at multiplication and division with exponents today. We'll start by looking at multiplication with exponents first. So when we multiply numbers with exponents and the bases are the same, we can add the exponents and keep the base the same. So very, very important here is that the base has to be the same. So quick recall that this number here is the base, the number up top to the right as a superscript, that is the exponent. So here we have 5 cubed, or 5 to the power of 3, and then multiplied by 5 squared, or 5 to the power of 2. All right, so the bases are the same, 5 and 5. So the first thing I'm going to do is write this out in a factored form. So if I was writing this out in factored form, that would become 5 to the power of 3 would become 5 times 5 times 5, right? Because 5 to the power of 3 means 5 times 5 times 5. And then we have 5 to the power of 2. So we have times 5 times 5. All right, so what that becomes now is if you count all these 5s, the bases, 1, 2, 3, 4, 5. So it becomes 5 to the power of 5. So what you'll notice here is that if you added the exponents, 3 plus 2, you would end up with the same answer. So the other thing here would be 5, and the exponent I'm just going to show up here is that we added 3 plus 2, like so, which still gave me 5 to the power of 5. All right, so again, with these exponent questions, the law here, this product law, is that if the bases are the same and they're being multiplied, then you can add the exponents. All right, so here we have 7 to the power 7 squared times 4 cubed times 7 to the power of 8 times 4 to the power of 6. So the bases have to be the same. So that means we can collect together the 7 squared and the 7 to the power of 8, and then we can collect together the 4 cubed and the 4 to the power of 6. Okay, so that would become the base of 7. We can add the exponents, which was 2 plus 8. So I'm just going to show that step. We are collecting those exponents together. We're adding them. And then it's still multiplied by 4. And the exponents are 3 and 6. And they are all being multiplied together. So we can add the 3 plus 6. So 3 plus 6. And the final form, when we leave this in exponential form, would be 7 to the power of 10 times 4 to the power of 9. All right, so if the question asks you to simplify the question and leave it in exponential form, this is where you would stop. We've simplified it. The next step here, if the question was to calculate, then you could obviously just calculate 7 to the power of 10, calculate 4 to the power of 9, and then multiply them together. All right, here are some more examples of multiplication. So again, read the question carefully. So it does say here, calculate each of the following and leave the answer in exponential form. Okay, so we have the first one, 3 to the power of 8, and it's being multiplied by 3 to the power of negative 2. The bases are the same. That's what matters. The bases are the same. So we keep our base the same. And we're going to add the exponents. So 8 plus negative 2. That's a plus. All right, so 8 plus negative 2, that becomes 3 to the power of 6. So let's continue to the next example. So we have 5 squared and 5 squared. So those two can be collected together. And then we have the a squared and the a squared. All right, so 5 to this 5 squared and 5 squared, so we'll add those together. So 5, I'm just going to show that step again. It's 2 plus 2, and then for a as well, it's 2 plus 2. So we end up with 5 to the power of 4 and a to the power of 4. All right, so just in this example, there's no multiplication sign or those dots, but we know that anytime there's no symbol in between numbers or letters like this, it means multiplication. Okay, and last one here we have just variables. For our bases, we have an x, y, z, x, y, z. So same thing as before. We'll start with x, and we have x to the power of 4 and x to the power of 6. So we'll add those exponents together. So 4 plus 6, and then we have y, and y 5, and y5, so 5 plus 5. And then we have z power of 7 and z to the power of 3. So 7 plus 3. Looks like they're all adding up to 10. So the final here simplified would be x to the power of 10, y to the power of 10, and z to the power of 10. Next, we are going to look at division with exponents. So when dividing numbers with exponents and the bases have to be the same, we can subtract the exponents. The second way to do it is you can write the reciprocal of the divisor and then multiply. I'll show you that, but I think students usually find it easier to just subtract exponents. So let's take a look at our first example. We have 8 to the power of 5 is being divided by 8 squared. So again, the bases are the same, base of 8, base of 8. So the rule here, this quotient law, says that we can subtract. All right, so I'm just going to show you, that step here. So 8, and our exponent there will be 5 minus 2, and that gives me 8 to the power of 3. And if we were just leaving it as simplified form, that's it. We would just leave it like that. All right. A common mistake students make is when there's a negative exponent. It is still going to be, so here it's 5 to the power of 6 divided by 5 to the power of negative 4. So when you're writing this, your base is still 5, and it's 6 minus negative 4. So a lot of students, they forget that the exponent is negative, and they will just write 6 minus 4, which will be incorrect. All right, so it's still 6 minus negative 4. And that will give us an answer of 5 to the power of 10. All right, here is one we can look at, and I'll show you both methods. I'll show you the method where you can write the reciprocal of the divisor and then multiply. So let's do that method first. So the numerator is 8 to the power of 3 times 4 to the power of 4 times 8 to the power of 5. So we'll just leave that. And then we can write the reciprocal all of these. So it's 4 to the power of negative 3. So we can make that times 4 to the power of 3 times, here we have 8 to the power of 3. So we'll make that times 8 to the power of negative 3. And then we have times 4 to the power of 6. So we'll make that times 4 to the power of negative 6. So this is that method where you take the reciprocal and then you can multiply. All right, now we can collect everything together. So the base that has 8, 8, 8. So that gives us 8 to the power of 3 plus 5 plus negative 3, because now everything's being multiplied. So 3 plus 5 plus negative 3. I'm just going to write it like this. And then multiplied by 4. And 4 to the power of 4, 4 to the power of 3, and 4 to the power of negative 6. So writing that, so 4 plus 3, and then plus negative 6, like that. And that gives us 8 to the power of 5, so 3 plus 5 minus 3, that gives me 8 to the power of 5, and then 4, that's a dot to represent multiplication. 4 plus 3 minus 6, which is 4 to the power of 1. Okay, same question. Let's look at the same question and simplify it another way. So, this is the other way. We can look at our numerator first, and we have 8 to the power of 3 times 4 to the power of 4 times 8 to the power of 5. So we can work with our numerator first because we can collect 8 to the power of 3 and 8 to the power of 5 together. So we can add our exponents. So that would give me 8 to the power of 8, right? Because I added 3 plus 5. And then I'm multiplying the 4 to the power of 4. So that's the numerator. And then looking at the denominator, we can collect 4 to the power of negative 3 and 4 to the power of 6. So we're adding those. That would become, we would leave the 8 to the power of 3. And then we have 4, negative 3 plus 6, which is 4 to the power of 3. All right, so all I've done is I looked and simplified my numerator, and then I simplified my denominator, and now I can use my quotient law, which is subtract exponents when bases are being divided. So now we have 8 minus 3, which is 5, and then we have 4 minus 3, which is 1. All right, and we get the same answer. Okay, next example. So negative 6 to the power of 5, negative 6 to the power of 5. The bases are the same. The base is negative 6, the base is negative 6. And so therefore we subtract our exponents. So it's going to become negative 6, and then our exponent is 5 minus 5, and this has to be in brackets. And that gives us 0. So negative 6 to the power of 0. And if the question says to leave it in exponential form, you would leave it in this exponential form. If it was to evaluate, you know that anything to the power of 0 would equal to 1, so your answer would just be 1. We'll leave it in exponential form. All right, so next we have this question where our numerator, our bases are 5, 6, and 9, so we can't do anything to the numerator. We can't simplify the numerator. And then our denominator is also 5, 6, 9, so we can't simplify the denominator. So we can go ahead and just use the quotient law now and figure out each exponent by the quotient law. So we're going to subtract. So it is negative 3 minus negative 6 here. Okay, so I'm just going to write that out just so you guys have that. So negative 3 minus negative 6. So very important that you keep the subtraction as well as the integer as how it is. So negative 3 minus negative 6, and then it's multiplied by 6 to the power of negative 3 minus negative 5. So negative 3 minus negative 5. And then we have 9 to the power of negative 4 minus negative 3. Like so. Okay, use your calculator. If all of these like integers are confusing, I just recommend just use your calculator, type it in correctly, negative 3 minus negative 6, that gives you 5 to the power of 3. And then we have 6, -3 minus -5, that gives me 2. And 9, -4 minus -3, that gives me -1. All right, so we would leave it as that in exponential form. And this last example, if you look at all of our bases, they're all 7s, 7s, 7s. So you can choose to do the method where you do the reciprocal and then multiply, or you can simplify the numerator, simplify denominator. So I'm going to do that method. So we have the base of 7, -12 plus 6 plus 9. So -12 plus 6 plus 9. And that gives me 7 to the power of 3. And then the denominator, 7 to the power of 6, and 7 times 7 to the power of 8 is being multiplied, so we add. So 6 plus 8. And we get 7 to the power of 14. And now we're left with just division. Now we can subtract the exponents. So 3 minus 14, 7 to the power of -11. And we can leave it as negative exponents for grade 8. Once you get to the higher level math classes, it is expected that negative exponents will be put into positive exponents, but we'll leave it as this.